Hello and welcome back to the Cracking Fang YouTube channel. Today we're solving LeetCode 1701, average wait time. There is a restaurant with a single chef, and you are given an array customers where customers of I equals arrivals of I and time of I. Arrivals of I is the arrival time of the ith customer, and arrival times are sorted in non-decreasing order. Time of I is the time needed to prepare the order of the ith customer. When a customer arrives, he gives the chef his order, then the chef starts preparing it once he is idle. The customer waits until the chef finishes preparing his order, and the chef does not prepare food for more than one customer at a time, and the chef prepares food for the customers in the order that they were given the input. Return the average waiting time of all customers. So let's look at an example here and think about how we might solve this. So the first customer arrives at time 1, and his food takes 2 minutes to prepare. So he will get his food at time 3. So he will have waited a total of 2 minutes. Now the next customer arrives at time 2, and their food takes 5 minutes to prepare. So the problem here is that he'll get his food at time 8, but he arrived at time 2, so he waited 5 minutes for the food to actually be prepared, and then also he has to wait 1 minute for the chef to actually be idle. So this next customer actually waited 6 units of time. Now the next customer will order their food and it takes 3 minutes to prepare, so he'll actually get it at time 11. But this customer arrived at time 4, so between 4 and 11 he had to wait 4 minutes for the chef to be idle and then 3 minutes to get his food. So it's going to take 7 minutes for him in total waiting. So if we add all of this up, we're going to get 2 plus 6 plus 7. This is going to be 15. There's obviously 3 customers here, so the average wait time is 5 minutes. And basically this is how we want to solve the question. Is you'll notice that what we have to do is the amount of time that a customer waits, so the wait time of customer of I is going to equal to the difference between when the customer, how long they had to wait for the idle. So the idle waiting, so they have to wait for idling, their idle wait plus the preparation time. So if we know how long they had to wait for the idle, which is basically the difference between when they arrived and the chef prepared the last meal, plus however long it took them to prepare the meal, then that's how long that person had to wait. So all we need to do is, as we go through each customer, we basically just need to, just keep track of how long the person will be waiting for the chef to be idle. So basically we're going to keep track of the time when the chef can actually prepare the next meal, and then we'll add to that how long it actually takes to actually prepare the meal, and that's how long that individual customer will wait. And then we'll just add that to our final kind of tally, and at the end we just divide it by the total number of customers. So once we have that, obviously knowing the idle wait time, then he can start preparing the meal, and then we'll basically update the idle wait time, because probably the next guy will have to wait for the chef as well. So that's the general gist. We're basically going to keep track of the total wait time and the idle wait time, and we're going to use the idle wait time to update the kind of net wait time, and at the end we'll just divide by the number of customers. So let's go into the code editor and type this out. If it's still not clear, then once we write the code, it should be pretty straightforward. It's not that many lines, and I'll explain it as we go along. All right, we are in the code editor. Let's now type this up. Remember that we need 2 variables here. One to keep track of the time when the chef will next be ready to prepare, so the next time when he'll be idle, and we'll also need to keep track of the total wait time that's been waited by the customers. So let's define some variables to keep track of that. So we'll say the next idle time for the chef is going to equal to the net wait time, and obviously this is 0 in the beginning. Now we need to go over each customer. So we're going to say for customer in customers, and we need to keep an update of the next idle time. So the next idle time is going to equal to the maximum between the current customer's arrival time and the next idle time. So this is the case where actually there's a gap between when a customer got their order and the next customer. So for example, if a customer received their food at time 5, but the next customer doesn't come at time 6, then obviously we want to start the count from when they actually arrived. Otherwise, they have to wait for the chef to be ready. So if the chef is ready as soon as they arrive, then they can order it right away and they don't have to wait for the chef. Otherwise, they have to wait for the chef, which is why we take the maximum of when they place their order and when the chef will actually be ready to serve them. So if the chef is ready right away, then he can serve them. Otherwise, they have to wait. So this is going to be the maximum of those two plus however long it actually takes to make their order. So customer of 1. So that this will tell us the next time the chef is actually ready. Now what we want to do is we want to update the net wait time, and we're going to add to this the difference between when the chef is next ready, so when he'll finish this current customer's food, and when the customer arrived, because obviously the customer has to wait from when they arrived until the chef was ready, plus however long it took to actually build or make their food. So the difference here, so next idle time minus when the customer arrived is the total time they had to wait. Okay, so we do that for every single customer, and we'll basically have the total wait time stored in our net wait time. But remember, we need to actually divide this by the number of customers because it's an average. So the average wait time is simply going to equal to the net wait time divided by the length of customers. And I think we're actually guaranteed to have a customer, so we don't have to worry about a divide by 0 error. And we can simply just return the average wait time. Cool, so let's run this, make sure we didn't make any mistakes. Wait, what happened here? Oh, sorry, this should be customer of 0, not customers. Okay, there we go. Yeah, obviously it's the list. Okay, so submit this and it looks good. So time and space complexity, really straightforward. Obviously the time complexity, we need to process all of the customers. So this will be big O of n, where n equals to number of customers. For the space complexity, all we have is these kind of 2 integer pointer values where we just keep track of the, or not pointers, but just 2 integers where we keep track of some integers. So this is going to be constant space. So that is how you solve this question. Average waiting time, a bit of a tricky one. It reminds me of exclusive time of functions, except that one is much, much worse. This one is a lot easier. So luckily we managed to escape with a relatively easy question. Anyway, that's enough blabbing. If you enjoyed the video, why not leave it a like and a comment? It really helps me out with the YouTube algorithm. If you enjoyed the video and want to see more, then why not subscribe to the channel, and I will see you in the next one. Goodbye.